Hey everybody, Mr. Judson here. So today we just have three things we want to make sure we feel comfortable with. One is using our calculator to find sine, cosine, tangent, secant, whatever, of angles that are in degrees, minutes, and seconds. The second thing is we want to be able to, if I tell you that the cosine of theta equals some number, I want to be able to find that angle. And I want to be able to find it using our unit circle. Okay, that's real important. Now, when I say use the unit circle, I don't mean look at it. I mean, I know it and understand it well enough that I could draw a quick picture and figure out the answer. And I'll demonstrate what that means. And then the third thing is if I have a triangle with two pieces of information, let's say an angle and a side, I can find some other side using trig. All right? So let's do some examples here. Let's say that I want to find the, we'll start with the first one kind of easy. I want the sine of 24 degrees, 13 minutes, 4 seconds. How would I do that with my calculator? Okay. So let me pull up the calculator. Put that over here. And so I want the sine of 24 degrees. And so now the question is, how do I get the degree sign or the minute or the second sign in there? And if you look right here, the second function for this apps button is angle. That's where I go to get angle stuff. So second angle, and look right there. There's our degree sign. So option 1. So sine of 24 degrees, I got 13 minutes. So I'll go second angle, and I'll choose option 2 for minutes, and then 4 seconds. Now, I don't know if you guys noticed this, but there wasn't a second sign in there. If I do second angle, that R has to do with radians, and there's some other stuff in there, but I don't see the double tick mark. And it's actually located down here where the plus sign is. I don't know why it's here instead of with these two, but that's where it is, okay? So let me second quit out of this. I want to go alpha and then hit that, and there's my seconds. Close the parenthesis and hit enter. Okay? And that's all we got to do is just write down that answer. So what was that again? That was 0.410. Now, if they ask us to write down 4 digits past the decimal, well, then we just get the next one. Okay? Then maybe you guys try this one. This time we want the cosecant of 72 degrees, 41 minutes, 32 seconds. You guys see if you can get that. All right, so I know that the cosecant is the reciprocal of the sine, so that means I'm going to have to do 1 divided by the sine of 72 degrees, 41 minutes, 32 seconds. So that's what I want to do in the calculator. So 1 divided by the sine, and I got to get all this stuff in there, 72 degrees, 41 minutes, 32, and then I'll go alpha down here to get the seconds. And there we go. Now I just thought of something. There's nothing about these answers where in our head we go, oh yeah, that's what I was thinking I should get. This stuff doesn't register in our heads. What if I'm in radian mode? Like what if I forgot to check? And I might be. Mode, oh, I'm lucky, I'm in degree mode, okay? But if I didn't check that, I could go through and do every one of these and get the wrong answer. Okay, so make sure we're double checking the mode button. All right, so yep, I got the right answer there. 1.047. All right, one more. This time I've got the cotangent of 47 degrees, 8 seconds. You guys see if you can do that. Alright, so there's no cotangent button, and it's going to be reciprocal of the tangent, so I want to do 1 divided by the tangent of 47 degrees, 8 seconds. So if I punch that into the calculator, 1 divided by the tangent of 47, get the degree sign, and then 8, and minutes is down here, or seconds I mean. Whoops, what did I do wrong? Oh, interesting. So if there are no minutes, because I got an error message, I must have to do 0 minutes, 8 seconds. So let me see if I can get that into here. 0, and then I'm going to go second angle, option 2. And then, see, I need 8 seconds. Yep, let's try that now. There we go. All right, so if there are no minutes, we got to make sure and put a 0 in there. Otherwise, we get an error message. I didn't know that until just now. So I learned something new. All right, 0.932. All right, so that's one thing we have for today. Let me get you guys a problem with the second example. All right, so that's one thing we'll see is working with the calculator. The second thing is they're going to give us problems like this where they want us to figure out what that angle is in both degrees and radians. And what they're saying here when they say let theta be between 0 and 90, they just want us in the first quadrant. Okay, just get an answer from the first quadrant. And same thing over here. So we're just really asking, you know, what angle would you plug in there so that when you do the tangent, you're going to get 1 for an answer. Now, I know tangent is sine over cosine. The only way you get 1 is if both top and bottom are the same. So really we're saying at what angle would sine and cosine be the same? And here's what I mean when I say I want us to use our unit circle, but I don't want us to look at it. I want us to produce it on our own. So I'm going to say, here's a unit circle. There's my x and my y-axis. And in order for the tangent to equal 1, I believe that happens at that middle tick mark. Right? And it's because the coordinates are root 2 over 2, comma, root 2 over 2. And if I'm going to do sine divided by cosine and get 1, it means my sine value and my cosine value have to be the same. So I think theta either equals 45 degrees or theta equals pi over 4. There's my answer. And just drawing that picture right there is showing your work as to where these two answers came from. Right? I want us to get used to that. I know we don't like to show work all the time, but we need to. Okay? We need to get used to drawing this picture over and over and over again. All right? All right, let me give you guys one to try. All right, you guys see if you can figure out this one. At what angle does the secant of theta equal 2 root 3 over 3? Okay, go ahead and give it a shot. All right, so, you know, the first thing I think is important to realize here is most people prefer to work with sine, cosine, and tangent because those are the 3 basic ones. Those are the ones we feel the most comfortable with. So what I'm going to do is I'm going to say, well, if the secant equals this, then the cosine is the reciprocal of that. I'm just going to flip it over. So 3 over 2 root 3. And then I'll rationalize that. So I'm going to get 3 root 3 over 3 times 2, that's 6. And that'll reduce down to root 3 over 2. Aha, a number we recognize, right? So where on the unit circle does the cosine of theta equal 3 over root 2? And what I'm going to do this time, instead of drawing the entire unit circle, since they said let's just work in the first quadrant, I'm just going to draw that one part of it. Okay? So here's my xy axis. There's my unit circle. I'll put my 5 tick marks in there. So when I look at this, the cosine is not at the halfway point. So if, I know it's not the middle tick mark, so if I chose this one, I'd go down and go, oh no, it looks like the halfway point. So I'm going to go over to this one, just kind of go down here. That doesn't look like the halfway point. That looks like that could be 0.866. Remember that number in the calculator? That's what root 3 over 2 is equal to. So I think that's the angle I'm looking for. And so that's 30 degrees. Remember, each tick mark is 15, so 15 times 2. So theta equals 30 degrees, or theta equals, that would be 2 pi over 12, which is pi over 6. All right, let's try one more. All right, so we're just solving for theta. We want to know, where does the cotangent of what angle, where does that equal root 3? You guys go ahead and try it. All right, so kind of the same thing as before. I don't like to work with secants and cosecants and cotangents if I don't have to. So I'm going to say that the tangent of theta equals 1 over root 3. And I'm not going to rationalize this because when I look at the unit circle, I want to think, where do I do sine divided by cosine and get 1 over root 3? All right, let me draw my unit circle here, or at least a fourth of it. Here's my 5 tick marks. The tangent equals 1 in the middle, so I know it's not that. It's got to be on either side. And so let's just make a guess, right? I'll make a guess, and if I'm right, that's great. If not, I know it's the other one. So I'm going to guess this one. That does not look like the halfway point, so that would be root 3 over 2. Okay, that does look like it could be the halfway point, or at least it's a lot closer than this. So that would be 1/2. And so when I do the tangent, if I do sine divided by cosine, and remember we said we could just look at the numerator, right? Because when you do this fraction divided by this, you're going to have to flip the bottom one over and multiply, and the 2's will cancel. So I'm just thinking sine divided by cosine, 1 over root 3, that's what I have. That must be the angle that I'm looking for. So yeah, once again I got theta equals 30 degrees, or pi over 6. All right, let's try one more type of problem. All right, so what we have here is a picture of a triangle. They're asking us to solve for x, which means figure out the length of this side. So I need to look at this and think, okay, which trig function, based on this angle, see this is the opposite side, this is the hypotenuse, which trig function uses opposite and hypotenuse? And whenever I'm asked to do something like this, kind of same as before, I want to work with sine, cosine, and tangent. I don't really want to work with cosecant or secant or cotangent. I want to stick to the main 3 if I can. All right? So I look at this and go, okay, opposite over hypotenuse. If we just write down so, ka, toa, there's the one that uses opposite and hypotenuse. So that means I want to work with the sine function. So the sine of 60 degrees is going to equal x over 18. So to get x by itself, I just have to bring this 18 over here and multiply. So I've got 18 times sine 60. Now if you want to, you could draw a unit circle and try and figure out what the sine of 60 is. It's going to be root 3 over 2. So you have to do 18 times root 3 over 2. If I had to find an exact answer, that's the way I would want to do it. But if I don't have to find an exact answer, well, then I could just grab my calculator and go, let's see, 18 times sine 60. There's my answer, 15.588. Okay? But if they ask me to find an exact answer, Well, then I'd have to go 18 times, I picture my unit circle here. "60 degrees is right up here. If I come across to the y-axis, that does not look like the halfway point. It's going to be √3/2. And so let's see, divide both of these by 2, I get 9 and 1. So my answer here is 9√3. And if I punch that in the calculator, that's the decimal that I'm going to get. Okay? All right, let me get you guys one to try. All right, so let's see. We're looking for x. It's on the hypotenuse. We know this angle right here. We know this side is 20. That's now the adjacent side, right? Because the angle we're referring to is up here. This is now the opposite. This is the adjacent. Hypotenuse is always opposite the right angle. All right? You guys see if you can do this. All right, so if that's adjacent and hypotenuse, if I think so, toa, we're using adjacent and hypotenuse. So we're using the cosine this time. So the cosine of 45 degrees equals adjacent over hypotenuse. So probably want to bring this x over here first. So I've got x times cosine 45 equals 20. Now to get x by itself, I'll bring this over and divide. So I've got x equals 20 over cosine 45. And again, I could punch that in the calculator if I want. Or I can think unit circle. So cosine 45, 45 is in the middle. It's in the first quadrant, so that means that's √2/2. So if I want an exact answer, I've got 20 divided by √2/2. I got to flip it and multiply. So 20 over 1 times 2 over √2. That's 40 over √2. And then you got to rationalize it, so it's going to become 40 √2/2. And then you do 40 divided by 2 and get 20. So 20 √2. There's our exact answer. Or I grab the calculator and I'm going to do 20 divided by cosine 45. 20 divided by cosine 45. And there's what I get, 28.284. So if I do 20 times √2, does that give me that same number? 20 times the square root of 2. Yep, exact same number, digit for digit. So I'm happy with either one of these, unless the directions say give an exact answer, then we need to do this one down here. All right, you guys, that's what we have for today. Doing degrees, minutes, and seconds on our calculator. What was the other thing? Trying to solve an equation for an angle. These are going to gradually get more complicated, but they're going to start us with something easy today. So solving for an angle. And then the last thing is trying to find a missing side in a triangle. All right, let me get you guys an assignment. All right, so this is our Wednesday portion. We got page 309. We're going to do 43 to 61 odd. We're going to do just part A. There's a part A and B for each of these. We'll do just the A part, okay? All right, so there it is. So Friday we'll meet as a group. I'll have my equipment down in Oregon, so I'll be able to meet with you guys on the computer. And we're going to talk about something that's, some people find this to be a little challenging, okay? Some people love it. What I found is if you're the kind of person that likes puzzles, you kind of like this kind of problem. If you hate puzzles, yeah, you're probably not going to like it as much. So anyway, we'll cover that on Friday, and I will see you guys then. All right? Take care. Stay safe.